Hey everybody, this is Chris with Overclockers Club. I've got something cool here from MSI. And here I am in the middle of August with all of the wonderful heat and humidity. So what better time to review a cooler than right now? Of course, this probably won't keep me cool, but hopefully it can keep your CPU cool. So this is the let's see, this is the Coreliquid 360R mag. It supports the Mystic Light, which is part of the MSI Rgb stuff on the motherboard. Let's see what's going on the back here. If I can keep the glare off of, I'll tell you what I'm going to do. I'm going to go ahead and pull this plastic off of here first. All right, so I'll just prop this up. This is really glossy, so there's still a lot of reflection, but I'll use this box. Oh, hey, look at that. It's the MSI A750GF power supply. Box comes in handy. Hey, you can check out that review too if you're in the market for a power supply. Okay, so I've looked at a lot of these. As you can see there, liquid coolers. I've got more over there, all kinds of good stuff. And, you know, I kind of look to see, okay, so what's different? And you got a radiator, you've got 3 fans, you've got a pump. You know, what sort of sets one cooler apart from the other? Because performance between them is pretty similar. But I think this one here, let's see, it says it's got radiator pump design. The pump has been integrated into the radiator for sound dampening and noise reduction. So that's going to be interesting to see. We also have rotatable block head is designed to be versatile, capable of spinning and turning to your heart's content. Rotatable blockhead, so here we go. So we'll have to look at that, up to 270 degrees. High thermal dissipation, that's good. Of course, that's what you want in a cooler, right? A split liquid pathway through the radiator rapidly dissipates heat. Cooled liquid is pumped back into the loop. Again, that's pretty much how these things function. Let's see, this side, not much going on there. Okay, on this end here, we've got, get that propped up. The basic specs, so you've got your socket coverage, which is pretty much all of your current Intel and AMD sockets. Radiator dimensions, nothing interesting or unusual there. Fan speed, okay, so 500 to 2000 RPM, so we can get some decent fan speed. 34 dBA or decibels on your fan noise. 4-pin PWM fans. Fan lighting, Rgb, and okay, so the pump goes up to 4200 RPMs, 3-pin, 12-volt DC. Okay, so yeah, I didn't realize. I guess looks like it does have RGB lighting integrated into the fans, and looks like maybe some in the top of the pump. Of course, yeah, it's got the Mystic Light RGB. So first thing I looked at earlier. Let's see, next I'll figure out how to get the box open. So the trick really with testing this is when I compare these, I need to keep everything as apples to apples as possible. So I use the same motherboard, same testing software, same overclock. Really the big variable, really is the season, and right now it's summer, so it's pretty hot, and it can be a little bit of a challenge keeping the room at the right temperature, because in the winter I keep it about 68 in here, and I test all my coolers at that temperature. In the summer it's a little more of a struggle to get the temperature down and keep it at that level. So we got the 3 120 millimeter fans. As you can see, sort of the translucent nature of the fan blades there is a good indication that we've got LEDs in there. There's your hardware kit. I'll open that a little later here and we'll see what's in there. And let's see, so here is, now it said that unless I misread that, it said that the radiator was integrated with the pump, or the pump was integrated. Okay, this is interesting here. There's a block with a power cord coming off there. So that's interesting. I'm going to have to look into that a little more and figure out exactly what I'm looking at. I gotta say, all the radiators I've looked at over the years, I've never seen one set up like that. Because usually this is where everything is happening. Your pump is usually right here. Of course, it's got, well, this only has RGB connectors. 3-pin, 5-volt. So, yeah, I guess the pump actually is integrated into the radiator. That is really something. Okay. Well, excuse my amazement there. That is definitely a first. Okay, let's go over some of the details now that I've gotten over the initial shock of seeing what appears to be some sort of a pump mounted in the radiator. And I don't know, I might take this apart and kind of see what's going on underneath this plate at the risk of leaking fluid out. I might do that after I do all my testing. But we'll see a little later if that's worth digging into. So on the edge of the radiator here, they have the MSI logo sort of printed there, which is nice. Let's see, is it on both sides? Yes, they've got it on both sides of the radiator. The other thing I notice here is, gotta be careful with that cold plate. There is a fill port. It's got a little rubber stopper there. But there's the fill port, and it looks like it's got a Torx screw in there. Now, normally, you don't ever, pardon me, you don't ever have to really get in there. Once they fill these up from the factory, your level should be something that you don't ever really have to top off. And see if I can hear the, sometimes you can hear a little bit of air in there, but I barely hear any at all, so they must have that pretty full. Sometimes you can shake these around a little and you can really hear the air that's at one end really sloshing around. But the other thing, what I notice really is the way that the tubes attach to the tank here. Typically the way these work, flip it around the other way. You see right here, there's usually a baffle right there. You can see those little dimples. And there's a baffle in there. So your coolant just doesn't come in one side and go to the other end. It comes in on one half, or sometimes it's a 60-40 split. So your coolant comes in on one side and travels down the length of the radiator. So it travels down 360 in this case, since it's a 360 millimeter long radiator. So it goes down 360. It makes a U-turn down here on this end, the shallow tank. So the coolant all comes to this side, and then it makes a return trip, another 360 millimeters to the other tank, and then there's usually your tube on the end there, and it takes it back to the pump. So in this case, you can see it's sort of split a little differently. We've got one tube on one side, but the other one's almost in the middle. And if I look here, it looks like that baffle is right in the center of the tube. So that's a little different approach. Looking at, I'll put that little plug back in there so I don't lose it. So looking at the cold plate here, of course, again, this is usually where your pump is, but there's no pump there. This only has RGB, an RGB socket or connector. Actually, there's a male and female to control the RGB effects. And this head, it's a little hard to move around without twisting things. So you see this actually rotates. They said it rotates up to 270 degrees. So you say, well, what's the big deal? Why would anyone want to rotate the top of their cold plate there? Well, when this mounts on your motherboard, you know, this can mount in many different orientations. And when it does, sometimes your logo is kind of jacked up. It might be upside down or sideways, depending upon the orientation. So no matter how you mount this on your motherboard, you can come in and rotate this so the orientation of the little dragon there, the little logo, changes. I think that's what they're trying to achieve there, regardless of how the base here is attached. We'll have to look at the attachment hardware in a little more detail too. But the diameter of the lines in millimeters here, get my trusty calipers out, looks like these are about a little over 12.5 millimeters. Of course, I can't really measure the ID of the tube, and that's what's the important part, but these are both about 12.5 millimeters in diameter. The other thing I noticed, the bottom of this, of course, is machine flat, and it's copper, and there's a protective plastic cover. Now, I always leave this on until the moment that I'm getting ready to install it, or actually installing it to the motherboard, to protect it, because you don't want to scratch that up, you don't want to ding it, or you don't want to have any surface imperfections. You want that to be just as smooth. So I leave the sticker on, but you do want to make sure you take it off. Sometimes in all the excitement of putting your new cooler on there, you forget, and then it takes you a moment to figure out why your thermal performance is horrible, because you got this big piece of plastic on there. But no worries, you can quickly remove it and patch everything back together. Let's see, what else? Nothing else is really remarkable about the radiator other than the way they have the pump configuration. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 tubes. And the thickness of the radiator, let's see, I've got, since my calipers won't, they can't squeeze down because of the frame here is thicker than what these can pinch down to. What I do is I take these little 2 pieces of aluminum and I zero my calipers, so that's 0. So now when I put these on here and then measure the distance, I get the true thickness, and it's about 16 1/4, actually about 16.3 millimeters thick, for anyone who wants to know. Let's see, okay, I think I already showed this earlier. This does have a 3-pin connector coming off to power the pump. Now I've got a thermal camera. We'll look at the thermals on this too and sort of see with the pump here how that affects the thermal imaging. Now, I know what most radiators look like that I've used the thermal camera on, so it'll be interesting to see if this one here is any different. So really the next thing is to look at the fans. And these are 120 millimeter fans, and again you can see the fan blades are sort of translucent, so that the LED array in there, they usually do a pretty good job of shining through all of the fan blades to project the RGB lighting. So we've got little rubber pads at the corners there for vibration dampening, noise isolation. We've got some strain reliefs there in the fan frame to sort of keep the wires from pulling on the solder points there on the circuit board. For the fan motor, there's the little MSI Dragon logo on the center, and there's a little bit of a reinforcing rib down in there, because when you tighten these in a case, sometimes when you use or when you use the fasteners to secure them to the radiator, you got to be careful you don't tighten too much, because you can sometimes break these if you tighten them with a little too much force. Okay, connectors here, there is a 4-pin PWM connector right there for the power, and then we've got the RGB connector, and again we have a male that's protected with this little plastic cap, and a female, so you can connect these, you can sort of chain them all together. As for length on the connectors here, I've had people ask in the comments sometimes, how long are the cables? So the main power cable here for the fan, I'll measure this, it is roughly 13 inches long, and then the connector here for the RGB is, looks like it's going to be pretty close. Actually, no, it's a fair amount longer than the power cable. So that one overall is just under 22 inches to the first connector, and if we go, I should call this overall, about 25 inches overall. So it's about 22 to the first connector, and then you go all the way to the end, it's about 25 inches. Give or take, depending on how hard you stretch them. So that's about it for the fans. It doesn't really have any fan specs on the back. Some of them put the RPMs and such. This just says 12 volts and 0.3 amp. 2-ball bearing. So those are the fans and the hardware box, or hardware kit. It's more of a hardware bag. Should have everything we need for the installation. Now they do a nice job here on the quick installation guide. They show, let's see, you've got a little, sort of like a little bill of material showing you each item and how many that there should be. So you can sort of go through there and make sure nothing is missing, but those are the screws for the fans. A couple different mounting brackets. Sometimes they have, no, these don't have anything stamped on them. Sometimes they'll have, well, this one does right here. So this one says Intel. And this one here, yeah, this one doesn't have anything on it either. But that's okay. A little thermal paste. We've got a noise reducer. So this is usually, it has a little resistor in there somewhere to actually slow the fan speed down a little. That's how you reduce the noise. There's a little alternate connector here, so you can go from a Molex to a connector for your fan. So let's just say you had a power supply, you didn't have any, or you didn't, for some reason you didn't want to connect this to your motherboard. You can just drive it directly off your power supply through a Molex connector, little adapter. And this is your sort of 3-in-1 connector. So this would connect to your motherboard, for example, and then you can connect all 3 fans together here. And that's useful so that all 3 fans are connected and driven off of the same fan header, so you know that your fan speeds are all the same. So we have some more. Let's see, this says LGA 2011. This one doesn't have anything on there, but that's, I believe that's AMD. Here's another one. It says TR4, so that's an AMD socket. And I think, let's see, the instructions sort of walk you through all of your different sockets. Sort of shows right there, making sure that you peel the little protective label off. Just a little reminder. And then this shows you the configuration for your RGB and your fan, little mini fan adapter cable here to connect all your fans. All right. So now I need to get my test system motherboard, which is over here to the right, all prepped. It's a Z390 Strix from ASUS. I've got a 9900K CPU on there. And what I do is crank that up to 4.9 gigahertz using AIDA64 to stress test the system, build up some heat, and then we'll look at how well, or what our maximum temperature is and how well it controls the temperature. We'll sort of look at some of the LED functionality, and that'll be a matter of just connecting it to the motherboard, controlling it with the Armory crate system on the ASUS motherboard, and that's really about it. So now I can get it installed. So part of the installation is sort of getting everything prepped, and this is, since this is an Intel installation, I'll be using this bottom bracket. So this is what will go under the motherboard. And it's got a couple little holes on each end, and again, depending upon which socket you use, the instructions show you which one of these holes in this series you'll be using. And here's the top bracket again. This is for Intel, and you notice these all have sort of a horseshoe shape to them, and since this one here is for Intel, it matches this bottom bracket here. But this goes on, there's a little groove here on this base here, and you line that up, and it sort of slides in there. I gotta find the sweet spot But once you find that, it should go, there we go. So it sort of slides right in there and snaps into position. You want to make sure it's fully seated. And of course that makes it easy to remove too. You just pop it right off there. So now I have to sort through the hardware here. And you know, after a while, after you put enough of these coolers together over the years, you sort of get a feel for what pieces you need. And like I said, I've done this for many years now. And for the most part, these things are all fairly similar the way they mount. So it looks like they give you one little extra piece there. And then these are the vertical studs. So what we do, and on this particular socket for this motherboard, I'm going to be using the inboard hole instead of the outboard hole. So I'll use the one closer to the center. And there's a little D shape, and that's sort of an anti-rotation feature. So you fish that up and in there, and you can see the flat on the back. So it kind of only goes in there one way and then sort of seats properly. And then there are these little retainers that you push over, and it's a snug interference fit. And what that does, when you snug that all up, that just keeps the stud from falling out. And we'll do that to all four corners. And now I need to push this up from the bottom, and then these little spacers here will go on top. Then this goes over the top of that, and then these little spring-loaded retaining screws will go on as the last step. So let me change the camera position so you can see what's going on. All right, so I'll get the bottom bracket here. I've got a hole cut in the bottom, actually. Zoom in a little so you can see what's going on. So I've got a hole cut in the bottom of my little homemade test bench here, and I need to get these little spacers on there. And hopefully there's a little bit, there's a little bit of interference when it goes over the studs to keep the bracket from falling out. Okay, so now I need to get the thermal paste on, and let's see, everything looks good from underneath. It's good to sort of check out. I'll move the camera here so you can see. If I can get it to focus, there we go. So there's the bracket from underneath. Usually there's a nice big hole cut in the back of your motherboard tray so you can get your pump bracket in there. So we'll get the thermal paste on. And there are 1,000,001 ways that people use to put their thermal paste on. Everybody has a little different technique. I just sort of put little dots everywhere, and you know, I've tried different methods over the years, and I don't really have one that is that much better than the other. I just sort of put a pattern on there. Like I said, I've tried many different ways, and I haven't really found one that's a whole lot better. So now it's time to get the sticker peeled off. And then, now for me, since I'm testing outside of a case, it really doesn't matter what orientation this pump is in. Let me zoom back out a little. I should say this is the cold plate. Get that over all of the studs. And I can feel that it is engaging with top of the CPU. Now I just need to put these fasteners on. And what I usually do is get them started, and then you come back and you tighten them in sort of a crisscross pattern. You don't want to tighten one all the way down And then the next one you want to do sort of an X pattern and tighten a little on each one. Make sure that's seated. And then what I do is I'll sort of do a couple turns on each one in an alternating pattern so that you apply a nice even force on the top of your CPU. And then eventually they'll bottom out and you're done. And then I just go back and make sure they're all snug. I always try to use two hands, especially on that final torque, because if your screwdriver slips as you're pushing down, it's easy to bury it into your motherboard. And running a screwdriver into your motherboard is not a good thing to do. Okay, that appears to be secure. If there's an issue with this not being seated properly, you'll know right away when you fire it up, because you'll see your temperatures will just be unusually high. And after you've had a system for a while, you sort of know where your temperatures should be, especially with a 360 millimeter radiator here. So every once in a while I'll get one that's not seated properly, or maybe all of the thermal paste squished out of one side, and I'll have to go back, take it apart, clean the thermal paste off, reseat it. It's usually okay. So now, okay, so this is my RGB connector. I guess it really doesn't matter. I can go ahead and connect this now. And since it's got the male and the female connection, then I can chain all the others into it. So my connector here on this motherboard is over here. Now this, again, this is a 3-pin. Actually has 4 slots, but there are actually only 3 pins that are used. This is for 5-volt RGB control. And they sort of do this to make it, for lack of a better word, idiot proof. So this header here has 4 pins. This is a 12-volt header for like an RGB strip, but you don't want to try and force any of these that are not. It even says right there 5-volt plus 5 volts, and usually one's a ground and one is a signal. But so it's V5 plus, a D, and a DNG. Anyway, regardless, we'll connect this end here. And then I'll leave this end covered for the moment. The next thing I need to do is get the fans installed to the radiator. Get this positioned over here. And of course I have the connector for power to the pump. And that I will connect to the header here. Let's see. Get my bearings. There should be, yeah, there's a CPU option and a CPU fan. We'll connect this to the CPU fan. Well, actually, no, this particular motherboard has a dedicated, let's see if I can find it. It has a dedicated water pump header, which is actually over here. And the CPU fan, actually this special cable here, the 3-into-1, this is the CPU fan, and this is where your fans connect. So this goes to the CPU fan header. I'll leave the CPU optional open, and then all of my fans for the radiator will connect to these 3 connections here. Years ago, your motherboard just had a CPU fan and then 1 or 2, maybe 3 chassis fan headers, and that's it. And now your motherboards have, like I said, you've got a header here for a water pump. There's several different, they're listed differently. This here is for the M.2 fan, this connector here. That's a chassis fan. I've got another one over here that is for, let's see, chassis fan also. And actually the other one over here, now that I look at it, let's see, this says water pump, but this one up here actually says AIO or all-in-one pump. So I guess I'm just going to go ahead, since this is an all-in-one cooler, I'll plug that up there. It's a little confusing because, like I said, it used to be you just had chassis 1, chassis 2, chassis 3, and that was it. So this is a fairly new motherboard to me, so I'm still getting used to all of the different connections on there. So one thing you want to try and avoid is one of these little torque drivers. It's fine for taking screws out, but when you put screws in, it's real easy to strip them out of your frame or strip through the plastic if you use the other type of fastener you know, that you attach a fan to a case with. So like I said, I use these to take screws out. I try to not use those to put screws in. Okay, so the first fan, we'll go ahead and use the trusty manual screwdriver and get this one started. And then we'll go ahead and speed this up. All right, I'll fast forward through here as I get the top fan, the middle fan, and the bottom fan attached. And again, I'm using a manual screwdriver to torque the fasteners. All right, now I can get the connectors for each fan. And I'm not too worried about cable management here or making things all pretty, because we're just testing this cooler right now. Actually, I'll put this one here and this one over here. All right. So the fans are connected. Next, we'll get the little RGB connectors rolling. So it looks like I can go like that, and then bring the last one here into the mix. So we're just going male into female, walk right up the chain of fans, and let's see, actually I did that wrong. I need to go okay, like this. All right. So that'll work. We'll go, and it really doesn't matter the order because they're all going to work off of each other here. And then this comes down here. All right. So I just had it backwards at first. So the moral of the story is start at the motherboard and work your way to each fan. And then I'll put a little connector cover on that last one. Okay, so other than the little wiring mix up there, everything seems to be pretty straightforward. So I need to get my power supply hooked up since I just took this out of a case review. So I will do that next. And the power is on, no issues. And you can see the RGB effects there on, I keep wanting to call this the pump. It's not technically the pump. It's like the top of the cold plate. But you can see how you can rotate that around to get the dragon in the right orientation. I guess maybe like that. And there's the RGB running on the fans. Of course, it's controlled by the motherboard where everything is plugged into this header right here. And so far, I don't feel too much. I mean, I can feel a little vibration. I don't know how much of that. I think it might be the pump right there. I mean, you can just barely feel it where you touch very lightly. I can't hear anything. I mean, unless I get my ear right up against it. but that's pretty normal. So the next thing I need to do here is the fan tuning. So I'll use the ASUS software to tune the fans and optimize the fan control. And the fan tuning has started, and what it does is it runs the fans from their maximum RPM down to 0 and sort of maps the voltages at each different RPM level, I guess you could say. It's just a way of calibrating your fans so that you know, or I guess so the system knows that at a given voltage the fans will run at a certain RPM. And that just takes a couple of minutes, but it's something I always do. Of course, the pump over here is also plugged into the motherboard, so it's also optimizing, where is it? Plugged in over here somewhere. It's also optimizing the pump RPM between 0 and its maximum too. And I caught it here when it's at the 0 RPM, so you can see it's sensing what voltage causes the fans to start to spin. All right, so the overclock is cranked up to 4.9 gigahertz. I always throw an extra fan on top here to sort of keep the rest of the motherboard cool. And I'll get the thermal camera out here in a minute and we can look at what the thermal imaging shows on the radiator. And I actually went to the MSI website, and there's a lot of good information there about this radiator, this whole cooler. And there's a nice exploded view of the pump. So I'll post that, sort of answers a few questions I had, as well as a nice graphic that shows the path of the coolant through the radiator. I was a little bit wrong what I was thinking about that. So the thermal camera should show what this image I'll post here in a little bit will show. But anyway, we're at 4.9 gigahertz, AIDA64 doing the stress testing. I'm holding at about 70 degrees Celsius. Temperature in the room is a little over 74, yeah, almost 75 Fahrenheit. And here's the graphic that shows the radiator and how it functions, which was very different from what I was initially expecting. But you can see clearly the coolant comes in from the side tube at the upper right, and the tank there must be chambered so that the coolant is split between both sides of the radiator. So the warmer coolant goes down the left side and the right side of the radiator. When they get to the bottom of the radiator, you can see the coolant, which should be cool at this point, changes direction, and it all comes up through the center of the radiator where it meets the pump, and then it gets pushed back out through the center tube. So different than what I've ever seen before, and we'll actually see this demonstrated in the thermal imaging, which is coming up next. And here is what the thermal camera shows, and it is very different from what I was initially thinking. Typically the coolant comes in one side of the radiator, travels down, makes a U-turn, and comes back up the other side. But you can see here clearly the hot coolant is going down the far right and the far left. And then it goes all the way down to the bottom where it makes the U-turn, and then it comes back up through the center of the radiator, which is exactly what the graphics shows. So the coolant, I should say, cooler coolant, is on the middle tube here. You can see it's about 24, a little over 24 C. And on the hot side, we're coming in at close to 29 C. And again, you can definitely see the pattern of heat going down to the radiator. Of course, the pump is right there in the center. If we look at the other side, the radiator side, of course, you can see a little warm area right there in the middle where each fan motor is. And then looking at the motherboard, of course, there's a fair amount of heat over there on the VRM when you are overclocking. That little fan on top, though, helps keep the motherboard temperatures down a little bit. Normally in a case, you've got airflow going across your motherboard. Out here on the test bench, not so much. Anyway, this is really interesting. Earlier I talked about disassembling the pump, just out of curiosity to see what was behind that mysterious black plate, especially since I'd never seen a pump located in the middle of the radiator like that. But I was able to find this nice exploded view from the MSI website, and really takes all the mystery out of it, you can see what all is going on. There's just an impeller and a bunch of coils, housing, O-ring, and that's about it. So running at 4,200 RPMs, it appears to be quite capable of moving a sufficient amount of coolant through the system to give you the numbers that, at least the numbers that I'm seeing for my system. And here's something that's a little interesting you may or may not be aware of, but you can actually lose a little volume of your coolant through evaporation through these plastic tubes. Believe it or not, that's actually a thing. So to combat that, manufacturers have tried a variety of different materials to help reduce or eliminate that. And I would think, I've never had a problem with it all the years I've used liquid coolers, but I would think it would take a very long time. But anyway, MSI uses a triple ply plastic tubing along with this mesh, outer woven mesh sleeve, I guess. And that's all in the effort to help reduce or eliminate evaporation. So overall, the performance, I'm pretty happy with it. I mean, it's a 9900K CPU, and there are so many variables that come into play when you talk about the performance of a cooler. What type of case you have, the location of the cooler, whether you have a graphics card that's dumping a ton of heat into the case, and again, the location of the radiator will play into that also, because if you have a top mount on your system and you're pulling air in from inside the case, well, if it's heated up already by the GPU, then your efficiency will take a hit on the radiator. But if you put the radiator in the front of the case, for example, where you're pulling in fresh air from the outside, then you probably won't take much or any of a hit with regard to your graphics card. And one more thing I wanted to point out about the different series here. So what you have are the MAG, the MPG, and the MEG. And I'm just using the motherboards here as an example. But they're basically three tiers, or three different price points, three different performance levels, three different feature sets, whatever you want to call it. So the MAG is at the bottom, so you could call this the good. The MPG is in the middle. That's a little better. More features, more functionality. And the MEG is the top of the line. But again, as far as performance goes, I didn't see really much of a difference between this particular cooler and really most of the other 360mm radiators or all-in-one coolers that I have tested. One thing I'll say, MSI has certainly taken the pump to a new level. Literally, they mounted it right smack in the center, which is a cool idea. And it seems to be fairly isolated as far as sound and vibration. I mean, I have to put my ear right up against it when it's at the maximum 4,200 RPM. And even then, I mean, I really can't hear much, maybe a very slight buzz, but it's nothing you'll ever hear outside of the case. And on that note, the fan noise, these 120mm fans, when you've got them cranked all the way up, again, there's sound, but it's minimal. You're not going to hear it once this thing's installed in your case. Value, this thing right now is on Amazon for about $120, and again, that's right in line with other 360mm RGB all-in-one coolers. But I think MSI has something here that's unique with the pump in the center, and I like the way you can adjust that centerpiece there to rotate the logo around to get it in alignment with how the block there fits on your motherboard. Of course, that'll all depend on the orientation of your motherboard in whatever case you're using. So I think MSI did a pretty good job with this cooler. Overall, I would give this the Overclockers Club Gold Award. So that wraps it up here for the MAG series Coreliquid 360R from MSI. So this is Chris with Overclockers Club. Thanks for watching, and don't forget to subscribe.